There are acids and bases. Acids have a pH less than 7. Bases have a pH more than 7. And if it's the pH is 7, then it's neutral. Acids you see in daily life are like Coke or lemon, or in chemistry, nitric acid. Bases you see in everyday life are soap or bleach, and like water is a base. So those are some examples. Yeah, and then I'll just do a picture.
Oh, okay.
Properties of acids and bases. Now, acids taste sour, and bases taste bitter. Acids just feel wet, and it's dangerous to do it. But bases feel slippery and soapy. When reacting with metals, acids form salt, and then bases form salt and hydrogen ion. And then conducting electricity when they're in aqueous solution, they can conduct electricity. Otherwise, they cannot.
Neutralization is where you mix an acid and a base and you have no hydrogen or hydroxides.
The Bronsted-Lowry theory is a reaction between a base and an acid, and when it reacts, the acid makes a conjugate base, and the Bronsted-Lowry base makes a conjugate acid, and this is all by the exchange of a proton. So, yeah.
Igneous acid is a substance that dissociates in water to form either hydrogen or protons. So with acids, when it goes into water, it increases the number of positive H ions, and in bases, it increases the number of negative hydroxide. So, compare and contrast Arrhenius and the Bronsted-Lowry theories. Now, in the Arrhenius theory, acids always contain H+, and then with the Bronsted-Lowry, bases always contain OH negative. Bases don't need to contain OH negative, so the acids donate a proton to form H3O+. Now, the thing that's similar between these two is that in the theories, their acids are proton donors. Okay, first off, conjugate means joined together or coupled. So an acid that loses a positive H ion turns to a conjugate base. And a base that adds or gains a positive H ion equals a conjugate acid.
Strong acids have weak conjugate bases and weak bases have strong conjugate acids, and typically the strong one holds on to the hydrogen.
This is our conclusion. Acids have pH less than 7 and bases greater than 7. No hydrogen or hydroxide when acids and bases are mixed. Acid minus hydrogen plus equals conjugate base, base plus hydrogen plus, conjugate acid. Both define acid as a proton donor, and a strong acid or base has a weak opposite.